students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So yes, in our previous class we have studied about alkenes, we have completed the reactions of alkenes. So in today's class we are going to discuss about alkynes, okay. So we will be discussing about the nomenclature, the preparation, the structure and the isomerism of the alkynes, okay. So let's get started here, and yes, the WhatsApp link will be there in the description section. You can go there, join our WhatsApp channel so that you can get access to all the classes and notes. So now here today we are in part 7 about alkynes, where we are going to talk about structure, nomenclature, isomerism and preparation, okay. So let me go, okay. So this we have 3 more lectures to complete this chapter, okay. So weightage is done. Okay, so students, here is an important announcement. So as you all know, we are just 2 months left for our PU board examination, and it's really high time to gear up our preparation, right? So to help you with this, we have launched the PU2 Success Blueprint test series, where you can get 12 mock tests, which includes like 4 part tests and 8 full length papers. You will also be getting one-shot revision videos, doubt clarification classes and detailed video solutions with detailed explanation, okay. And all these were available, so please mark my word, all these were available at 599 rupees, but yes, now you can get a flat rupees 100 off on this, because we are giving you some discount, and you can avail flat rupees 100 off here by just, and you can get this at 499 by using our coupon code NY2025, okay. Now students, please do not delay, because this is not an unlimited offer, not an infinity offer. It has a deadline and this coupon will expire on Jan 10. So hurry up students, just go to the description section, click on the link and purchase it as soon as possible, because once the discount gets over, you will get back the higher price, okay. So yes, now coming to the next one. So we have the following things today to discuss about alkynes: nomenclature, structure, isomerism and physical properties, okay. Fine. Coming to alkynes, general formula is CnH2n minus 2, okay. For example, if you have so if you have C3, okay, so H2n, 3 2s are 6 minus 2. So C3H4, okay. So in alkynes what we have a triple bond between the carbons. So if I want to draw this C3H4, okay, now I need 4 H, so I have 1 H here, 1 H here, 1 H here. Now this carbon, all the 4 valency is satisfied, here 3 valency is satisfied and here 1, so it is C3H4, okay. Next we have the nomenclature. So for nomenclature you have to know that the triple bond suffix used is YNE, okay. So if you have 2 carbon, then it is common name is very important, acetylene, and the IUPAC name is ethyne, okay. Now if you have 3 carbon, it is methyl acetylene and it is the propyne, okay. And if you have here, then it is ethyl acetylene and it is butane, and butane can be like also but2YNE, okay. Next we have isomerism. So regarding isomerism, like if you remember, in case of alkenes, okay, we had structural isomerism as well as geometrical isomerism, right, cis and trans. But here it is very simple. In case of alkynes isomerism, we just have structural isomerism, okay. There is no geometrical isomerism. So I'll give you one example. Suppose you have a structure called as but2YNE. You have a molecular formula like C4, okay, and H6, okay. Now what are the isomers that is possible? So we can have like this, okay, so H6, right. So I'll put 3H here, 4, 5, okay, and 6, clear. Next I have C4H6, okay, and we have H here and H here, then we have H here, okay, clear. So but1YNE, but2YNE. Any other possibility we can have? So you can see you can have a 3 carbon chain, and here if I put one H, so if you have H, H and H, okay, here you have one H and here you have one H, Okay, so now if you see here, these two, this is suppose structure 1, okay, this is suppose structure 2, and this is suppose structure 3. Okay, now if you have structure 1 and 2, so here in between 1 and 2 there is double bond, here there is double bond between 2 and 3, right? So 1 and 2 and 2 and 3, so what can we say about this? These are the positional isomers. Okay, but now here if you see there are 4 carbons, and here if you see there are 3 carbons, right? So now here what the chain is of 4 carbon, here the chain is of 3 carbons. So what we can say here, that these are your chain isomers, because here the chain is of 4 carbons, here the chain is of 3 carbons. Now suppose if I want to name it 1, 2, 3, so how will I name? 2-methyl, okay, propyne. Okay, but here if I name it, it will be but 1-YNE, and this one will be but 2-YNE. Okay, fine. Next, if I see structure, okay, so during carbon-carbon triple bond if I have, okay, so let us just see a very simple structure of ethyl. Okay, so now this bond, okay, this is a you can see how many sigma bonds are there? 2 sigma bonds are there. So that means what is the hybridization here? sp hybridization, sp hybridization, right? So each carbon has 2 sp hybrid orbital. So you can see that here there is one sp hybrid orbital, okay, and yeah, this is one sp hybrid orbital, and this is another sp hybrid orbital of one carbon. Similarly, this carbon has one sp hybrid orbital and one hybrid orbital. So the one hybrid orbital of this carbon forms sigma bond with another hybrid orbital of another carbon. Similarly, it forms a sigma bond with this hydrogen, right? Similarly, here you can see we have one I can say sigma bond, and here there is one sigma bond. Okay, next coming to pi bond. Okay, how this pi bonds are formed? So this p orbital, okay, this carbon has 2 unhybridized p orbitals. Okay, these are unhybridized p orbital. So these unhybridized p orbital also form pi bonds. Okay, so there is overlapping, sidewise overlapping 2px and 2py to form the two pi bonds. Okay, sigma bond is formed by the hybrid orbital, and the unhybridized p orbital form the pi bonds. Okay, so this is the structure. Next, coming to preparation. So under preparation we have 2 methods only. One is from calcium carbide, another is from vicinal dihalides. Okay, so let us see their methods of preparation. Okay, so calcium carbide, first you have to prepare calcium carbide, then if you react with calcium carbide something, you will get calcium hydroxide. Okay, so to prepare alkynes from calcium carbide, you can react calcium carbide with water. Okay, so first we need to prepare calcium carbide. How can we do that? So quick lime, if you take CaO with coke to produce calcium carbide. Okay, so CaCO3, if you just heat it, you will get CaO plus CO2. Now if you take CaO with carbon, that is coke. Okay, so if you heat CaO with coke, you get calcium carbide, CaC2. Now CaC2 plus CO. Now react the calcium carbide with water. Okay, so CaC2 plus water, if it is there, you will get CaOH whole 2 plus C2H2. You have got your ethyl. Okay, that is the method of preparation of ethyl. Then there is another method, that is your from vicinal dihalides. Now what is vicinal dihalides? 2 adjacent carbons having the halogen groups are your vicinal dihalides, right? So how we can how we can increase this, how we can prepare this vicinal dihalides? So for preparation of how can we prepare alkynes from this vicinal dihalides? So we have learnt a reaction in alkenes chapter, that is dehydrohallucination, right, by using alcoholic KOH, right? So once, see here there is there, if you do alcoholic KOH, what will happen? First one HBr will be removed, okay, but there will be one more H and one more Br. Okay, so now to remove another molecule of HBr, you cannot use alcoholic KOH again, but we need to use sodamide. Okay, sodium NaNH2 if you use, then one more HBr will be removed and you will have CH double bond CH. Okay, so yes, that's all students. I've already discussed about this. So that's all students, we have learnt today about the alkynes preparation and the structure and all. In the next class we will be studying about the alkynes reactions. Okay, so I am taking very small part to complete this chapter, and that is why it is having more parts, so that you do not have to give more time. Just 10 to 15 minutes you can watch and quickly understand these chapters, these sections of the chapters. Okay, that's all students, thank you for watching, and if you have any doubt please comment down and do not forget to subscribe the